Hello guys, I'm Henry. I'm product manager for the AccuPick. So today I'm going to go through how you guys see the 3D bin picking and what is a robotic 3D vision. Also, what we can do for the AccuPick, and then we have a reference. So I will start from this picture. This is very general parts you can see in almost every factory. You see the metal, you see the plastic, you see some parts on the palette or in the bin, whatever. But those customer has one question in mind: how to deal with those parts when I do the robot pick, right? So traditionally, you will like to do a traditional feeder to kind of guide your parts into the same orientation, or you have to see in different faces, but bottom view or the top view. So what I mean traditional feeder is looking like this picture here. It could be bow feeder, it could be the conveyor handling by some guider, or it could be like a mechanical alignment or limited by some mechanical way. However, the 3D vision in general is with one single camera and powered by the software. So this is the huge difference, right? And I'm break down to the couple points to let you convince your customer or yourself, our end user. Think about this. The first point, flexibility, right? Um, Now our challenge is every day we have the new design of products. You kind of change your lines openly. You kind of have the new shape, new size. So the mechanical way has limitation. You have to fabricate. You have to change your motor or your guider every time. However, for us, the software is so much more flexible. We learn from the programming and click your computer, you can change the different SKU immediately. Second is about the footprint. So in the factory, I think the space equally to the money, right? So the mechanical feeder is usually more than 3 by 2 square meter, usually. But however, a single camera on the with a stand or on the robot is only 1 by 1 square meter for the max. Yeah. So think about this. If you use the vision today, you can increase more than 3 lines. What would you think? This is a lot of money to increase for the production line. And for the maintenance is also the point, because the mechanical feeder, it has some components, right? You have motor, you have bearing, you have a lot of build. So the most dangerous thing is you forgot to maintain those things. However, if you use vision, we have only camera and the projector. So it's very easy to maintain your equipment without any risk to shut down your production line. So that's another point. About noises, now the factory designed for user-friendly, operator-friendly environment. The vibrating table, of course, they have to make some frictions. They have to guide the parts. So noises is cannot be avoided, right? But for the camera, it's kind of muted functions if you compare to the mechanical feeder. And then there's about how easy to use when you have different parts, right? So for the feeder, sometimes even one feeder is not suitable for different size. You have to change your guider, you have to change another feeder. So those takes hours for sure. However, for the software, you click the computer and then you change the program. The final, but the most important things, I think, is the price. I would not say the vision is the most cheapest one, because some feeder could be small, but in terms of some medium size or the big size feeder, it's kind of complicated inside, right? So the feeder, you have to think about in general, flexibility, footprint, maintenance, noises, and those things combined together and calculate again in total general compare table. We are confidently saying we are competitive in the price in the general consideration. So that's how we beat with most of the challengers. And for the detailed price, you could contact to the local sales. I believe they will give you a happy price for sure. Right. So this is the not about Solomon only. I think this is for general 3D bin picking idea you can use. But here we have Solomon AccuPick general picture. We cover from the scanner, software, robot control, and the PLC. So for the scanner, you can have a different spec. For example, you have a different precision, budget. You can either use the Solomon scanner, 3D, or you can use the Intel RealSense for the budgetary scanner. Depends on your accuracy. And for the AI-based software, later on, Sumi will give you so much more how to use it. I'm going to just pass it here. And for the integration, the robot is, so compared to competitors, most of them are only sending you the picking position, but they're not considering the motion planning. Sometimes you have to think about how to avoid the bin hitting and how to pick, how to control the gripper. But that's the most amazing part because Solomon covered them all. In our interface, after you get the coordinate, you can also connect to the robot and do the motion planning, how to pick this part and how to avoid the hitting. Those are all in Solomon consideration. So I think that's a really big selling point for all of you guys. And also we can integrate with communicate with some of PLC like Rockwell, Mitsubishi, Siemens, or Moulin. Right. So for the eyes, it's about scanner. Of course, you will consider first of all the Solomon structuralized scanner. Every time the scanning, we will give you the like light pattern. This light pattern will help you define the depth of the parts. And under the 2D camera, we can see the XY. So in total, is a six-axis consideration when we go to pick. So this is a really simple demo. After you see the shining there, that's our projector generate the pattern light. And this camera is much more focused on the accuracy up to less than 1 millimeter accuracy. It's also done by us. So this is Solomon camera. And a lot of people complain about the price and also the easy of use. So that's why we integrate with the Intel RealSense. This is much affordable camera. You can Google on the internet. At the same time, it's really compact in the size. And also you can do with eye in hand. What I mean eye in hand is you can literally mount this camera in the end of axis. So I will show you the video. By the way, if you go to Intel RealSense Robotics Partner, you will see Solomon logo here. It means we are official partner, so you can give us more trust. So here, you can see this is the camera. We put in the end of arm, like the eyes of the robot. Every time if you want to pick something, the robot will go to take a look, right? And then analyze by our software, go to pick. So if you have more than one bin, for example, you have 6 bins surrounding you, it doesn't matter because the eyes always go with the robot, and it will always give you really high flexibility when you want to check every bit. So this is the Intel RealSense. It's our second popular camera in our production line. Okay, after the eyes scanner, we talk about the AI engine. So a lot of people question us, hey, Solomon, what's your AI? Why you say you are the AI-based company? So basically, I'm not a technical person, but I'm giving you the brief concept. We have a department who has a really genius brain to develop the algorithm for this neural network things. So when you input the pictures here, they will start to converge, or we say technically we say pooling. Pooling means we cut the pictures into like the square, like a pool, swimming pool, and we will take out only the features from the swimming pool and to analyze those features and converge those data into the final result. And then we compare this final result to our database, so we can find what is the most idea parts from these pictures. Here I have I have a simulation. This is like a neural networking. For example, today I write here, I write 3. So it's kind of ugly, right? But in the neural networking, it will start to analyze. You see a lot of blocks here. It's like a swimming pool I mentioned, and they will take out only the feature part, and to analyze the feature part into the next level. So they will converge those features data into the final result. So here we got 3 here, and the second guess is maybe like 1. So this is like the simulation for our neural networking. And for more detail, please contact again to the local sales, and they will give you so much more engineering detail. But what can we do for those AI-based technology? So in the beginning, we will analyze your part. Think about this. You have a part in the beam, and after deep learning, we can locate where's your part, how it looks like. For example, here we have the top view for the pink and the bottom view for the kind of green. And we also see the orientation on the basically on the text on the cover. So it gives us a lot of flexibility and available to fit all kinds of objects. We don't really need CAD file. This is really selling point. Some of the parts, like raw material, you don't have the CAD file, right? Sometimes your parts are shining, some parts are transparent. The CAD file just doesn't match with the parts. Or today your customer just hand you very random things. For example, they give you the paper or they give you the mouse. You couldn't generate the CAD file immediately. But with our software, you can just take in pictures using our AI-based engine and to analyze how it looks like. And we are able to locate these parts, and we match with the 3D point cloud generate by, I said, the 3D scanners. So this is much more flexible to fit all kinds of the objects. And it is a zero programming program. I mean, the software, you don't have to write any coding there. Basically, Sumi will show you how it works. We plug and play and we jack all the functions in the block. And also we can read 2D and 3D information. And final point I want to highlight is about the timing, because the cycle time is matters always in the production line. So in the fastest case, we can even scan in and get the result within a second. So this is about the AI engine part. And finally, I'm going to talk about the robot integration. You can see these pictures here. It's actually more than 20 robot brands already. We can integrate. What I mean integrate is I'm not going to only send you the coordinate, but I'm also control the robot 6 ASICs. So I can make a move, I can control the IO, and I can do the job. So this part will be also demonstrated by Sumi later on, how to control the robot to make the bin picking really easy. All right, so we go through the scanner, software, and the robot control. I'm going to guide you how to, when you got the parts, how you analyze it and what is the reference we have done. So generally we have 2 parts. The first part is for the manufacturing. The second part is for the logistics. For the manufacturing, usually you need a very high accuracy, more than at least 4 millimeters, let's say. So in this case, you have to do deep learning for the ID. How it looks like, what is the surface, you have to teach, you have to make it learn, okay? And sometimes the position could be random, completely random. This is the high-level bin picking applications. You have to think about the obstacle and also the gripper. And the second one, which we prefer, is semi-structured bin picking. It's shift in the position, it's arranged somehow in the middle way, but it needs our 3D scanner and software to locate the parts and do the pick and place. So you can do assembling, packaging, machine tending, conveyor pick, or loading and unloading, right? And another big general you can see is logistics. the spotlight for this one is always today coming the parts is unknown. What I mean unknown is today could be shampoo, tomorrow could be another pen. So we don't have time to do deep learning for those parts. And what we do is we use our neural networking to recognize the parts in 3D, and then we define the center point of the parts. So we go to pick with a lower accuracy, I will say around 1 to 2 centimeter. But the point is you can grip line up and do the packaging or pick and place. So that's about the, I will say using the parcel picking, warehouse order fulfill, or the kitting line, right? So different applications, both of them are using our scanner. Let's see some reference. Okay, so first reference, I would like to bring you the most smallest objects we ever pick. It's the 5 millimeter washer, and this is the real case. Okay, so you see this is the size of washer, and this end user is from the aerospace industry. What they do is they have around 50, more than 50 different kinds of small parts, and they need to do the kitting job by the order or by the demand of the assembly line. So the requirement in the beginning, they try to use the feeder as well to solve those problems. But you see, the feeder doesn't fit all kinds of shape and the size. Reason why, in the end, they design one Solomon scanner focus on the movable bin. So there is a conveyor coming. So when you have the pickable, I mean, you want to pick those parts, the conveyor will send a signal, come in and the scan and the pick and place, do the kitting, and then conveyor move. So this is the idea. And the challenging part is the things is very small. So we have to identify the center point of the ring, and then we offset to the border of the ring, do the pick and place job. Right. So if you have some parts more than this size, we are also confident we can recognize and do the pick like this. Um, Second, I want to bring you the transparent detection because this is something traditionally difficult to challenge. The light is an issue. If you have an environment light, sometimes transparent is somehow difficult to manage if you have experience. So here we use a one Intel RealSense camera, and then we deep learning the shape of the bottle, and then we can do the pick and place. You see here, so even though they are transparent, the AI-based engine can learn the shape and locate in the ideal picking position you want to do. It could be used in the medical devices, some glasses, or we have one application doing for the wine glass. Okay, and then I have the third application is doing the urn stacking. So the application is implemented in the China. You can see they produce those liquid. Before drinking them, you have to put them into the dungeon for about 5 years. They need a human beings to stack up those containers because they want to maximize the space, right? So here the integrator design one AGV together with robots, and the eyes, you can see Solomon scanner here. And we can recognize the top view of this urn and doing the precise picking. I will show you the precision of this pick is about 5 millimeter accuracy. So we can maximum stack up 3 layers, right? So it helps their laborers not really doing the tedious job again to move those more than couple kg things. Maybe they got hurt, maybe they don't like the environment. That's why we need to bring their eyes to the robot. Right here, we bring you the classic bin picking application, which is working with the CNC machine usually. So here you can see the parts has the top view and the bottom view. I want to focus on the things is bin collision avoidance in this case. So you can see the gripper is actually get really close with the bin border. We have the software to simulate where is your robot and gripper, and together with the obstacle in the environment, we can send you the coordinate without any hitting. So that's the idea of this application. You can see how precise it can be. All right. So not only from the beam, but also from the conveyor is also attractive for some of the end user. See here, the parts is for automotive, and the most important thing is they don't want to design any, let's say the tray, or they don't want to design the pusher, or they don't want to limit the conveyor to fit those parts. So what they do is they will manually feed in by the man there, and the parts coming with a 3D position. After that, we scan, we get the coordinate in the 3D, and then we place on the next station, right? So it's actually really easy task for us if it's handling by the conveyor. We have so much experience. This is like level one conveyor picking for us. So we can implement this application very fast. And here I have the robot unloading application. Okay, see here, this rake is internal in using in the factory. It's moving always from stations to station. So the parts I call fiber material bobine. When they are loaded on the rake, there is no way to always fix in the same position, like the National Geographic case. It's the same idea here. We don't need the human to align again, or the mechanical to do alignment, but after scanning, we can see where is the bobbin and precisely pick the end of the bobbin to do the unloading job. So I believe uh, this kind of application, you can open your mind and check in your factory. I believe you can see a lot of the rake application, and please come to us, and we can analyze for you the return on investment, and also which camera is suitable for you. Okay. So this is also automotive, because I believe still automation is kind of still dominate in the automotive factory. But this one is shiny and very tiny as well. So we have to recognize the top view and the bottom view of these parts. Together, we will work with the second alignment station to make the accuracy much higher, more than 1 millimeter accuracy. And then they will do the after process. But our job is to recognize where is the parts in shiny, and to recognize the bottom and the top. Okay. So I have a final, I leave the final biggest projects in the end. Due to the confidential issue, I can only show you this picture. This is our biggest case so far. We have in total 13 cameras doing implement this project in India. And the end user is a very global, well-known German company doing the manufacturing for the car, air condition. And take a look at these pictures. There are 3 points I want to highlight. The first is about space. So of course, we compare again with the feeders, vibrating feeders. But if you take a look, the space is actually really squeezing already. So they couldn't fit in more ball feeder in this scenario. and they will waste a lot of production line if they use a bow feeder. But instead, they have only used, and in the end of the conveyor, there's one scanner implement, and then one robot can work with the three scanners at the same time. So this is the first point. The second is about the cycle time. So when the parts are fitting from the conveyor, you don't have to do any pre aligned or pre arranged. So simply you scan and you see the parts, even they are overlap. We don't care. So in this situation, every time we scan, we got about 1.5 seconds. We got a coordinate. So the robot go to pick, and when they turn back, already we got the coordinate again. So we make the robot nonstop. And compared to bow feeder, first of all, you have to kind of prepare your parts in the vibrating table. And then in the end, you have the 2D camera to locate the parts again. So in total, the cost is actually, we use the more, I think, cheaper than the bow feeder plus the 2D vision. So this is really successful case. We compare with the traditional way, and then we win the bidding in the end. So think about if you have those conveyor feeding and you need to see the orientation of the parts and go to pick. I think we have a really good experience on site and we can serve you the best. So this is for the manufacturing applications. Not about the bin only. Think wider, because usually when I say bin picking, some customer already limited their application chance. But it's actually from the floor, from the palette, or from the anywhere. If you have a pick and place, like human being's eyes, you can use our high accuracy bin picking software. So in the end, not going to take too much time here. I'm going to go through some logistics picking, which I mentioned before. We don't need to do any deep learning because we don't do much high accuracy like manufacturing. So we can do order fulfill, process picking, or depalletizing things. For example, I'm going to show you the speed here. So those parts, we didn't do any training, right? You can drop whatever you want. I will locate the center point for you. And the cycle time is really matters because think about the human being hands is almost the same like this robot already. So if you have a 3 shift in a day, I think your return on the investment could be fast because we work in exactly like human beings. You could do some applications. For example, if you want to check the ID, so after picking, you can set up another barcode reading, so you can know where is the parts and what is it, and to put where. And if your parts are really condensed, I mean, it's densely arranged like this, we can solve for you because we have online production experience to solve those, I would say, compact pack situation. So you see, we are going to do the precise packing for this case. And finally, this is for the most common application in the every warehouse. You can see the stack of the glass here. The pack is not really in the neat position. It's kind of changed the final position. So what we do is we didn't do robot teaching for the pattern. Instead, we learn what is the surface and the pattern of the pack here, and then we locate in the center point, do the precise picking here. So it can be changed in the position. We don't care. Once you set up the scanner under the proper FOV, we can locate the parts and go to pick and place, even for depalletizing. All right, so final page. Thank you, gentlemen, for your attention. So 4 points I want you guys to keep in mind, even no matter you are end user or distributor. Solomon Solution Innovation bring you 4 points. First is we are AI-based company. As I mentioned to you, we have a great team for the neural network in developing. And second is we have different scanners for different budget, precision, and also the FOV cycle time. Third, we are able to control your robots, no matter they are KUKA, Kawasaki, or Fanuc, whatever. We should be able to develop some master control to do the motion control for your robots. So in the end, we provide one-stop solution, stuff from the scanner, software, and the motion control. So we try to make the bin picking as